Hello everyone. Now we have another question on motion of projectile. The question reads, the time of flight of an arrow fired with initial speed 30 meters per second horizontally from a castle window was 2.5 seconds. Okay, so this is the time of flight. That is the time for which the particle is projected or has been projected. Okay, now also we have that we want to calculate the horizontal distance from the castle of the arrow's landing point. Okay, that is from the castle, that's from the point where the arrow, all right, is fired horizontally to the point where it lands. So the maximum distance traveled, okay, or the horizontal distance traveled, which is what we know to be what range, is what we're asked to calculate in this case. Then we have again calculate also the height of the castle window above the ground. Okay, so in this question we're going to what we're going to be applying um, one of the equations of motion due to gravity. Okay, that's motion under gravity, and that's what we are going to use for us to be able to calculate the height of the castle window above the ground. But when it comes to the horizontal distance, of course, we know that because velocity measures distance over time. Okay, so that will be distance will be equals to velocity multiplied by time. And we know that the velocity in this case is the what? Horizontal velocity. Okay, because the arrow is fired horizontally. So now, according to the question, we know that now we are given the time of flight. Okay, the time of flight of an arrow fired with initial speed 30 meters per second horizontally from a castle window was 2.5 seconds. Okay, so which means the arrow is fired horizontally. Okay, so that means that the initial velocity will be equals to 0. Okay, then it means the only force acting on the arrow will be the what? Will be a vertically downward force, which we know to be what? Force of gravity, which will now develop a downward acceleration on the what? On the arrow. Don't forget that we want to calculate the horizontal distance from the arrow, from the castle of the arrow's landing point. Okay, and also to calculate the height of castle window above the ground. All right, so the horizontal distance. So first, we are given the time of flight. Okay, we are given this. We are given time of flight. Okay, time of flight is 2.5 seconds. 2.5 seconds. That's the time of flight. Okay, now we're also given the what? The horizontal velocity. So we have horizontal velocity. Horizontal velocity. Horizontal velocity. That will be ux. Okay, and that's given to be 30 meters per second. That's the horizontal velocity. Now we want to calculate first. We want to calculate the horizontal distance from the castle of the arrow's landing point. So which means to be able to calculate horizontal distance. Okay, horizontal distance. Horizontal distance will be x. Okay, and that is what we need to find out. Okay, so x equals to, that's horizontal distance, equals to the horizontal velocity. Okay, multiplied by what? Time of flight. So x represent the horizontal distance, and t represent the what? The time of flight. Ux represent the what? The horizontal velocity. Okay, so, and don't forget, in one of my videos, that's I explained that whenever an object is projected horizontally, okay, its acceleration, that's it will have no acceleration. That's the acceleration we call horizontal acceleration. So in this case, we have the horizontal distance to be equals to, now this value 30 multiplied by 2.5. So that will be, we have 30 times 25 over 10, and this will be what? 75 meters. So the horizontal distance is 75 meters. Okay, now also, now we have calculate also the height of the castle window above the ground. So the height of the castle window above the ground. All right, we want to calculate the height of the castle window above the ground. So we'll be applying one of the equations of motion under gravity, and that will be the equation for height, which is, in this case, it's going to be the vertical what? That's for vertical motion. We know that the initial velocity will be what? Will be 0. So we have ut, then we have 1/2 of gt squared. Okay, 1/2 of gt squared. So where t is the what? Time of flight. So we have that h will be equals to 0 multiplied by 2.5. Okay, that will be 2.5, then minus 1/2 of 9.81, then multiply by the time of flight, which is also what? 2.5. Then we raise that to the power of 2. So h will be equals to negative 1/2 of 9.81 multiplied by, now what is 2.5 squared? That would be 6. Yeah, that'll be 6.25. Okay, yeah, that'll be 6.25. So we have this to be 6.25. So h will now be equals to, let's get, what is 6.25 multiplied by 9.81? Okay, that will be, this will be negative 61.3125. Let's divide this by 2. Don't forget the unit of height is the what? Meters. So this is meters. So h will be, so let's divide this value by 2. Dividing this value by 2, then we have the value of time t to be, sorry, height h to be 30.66 approximately meters. Now, because height, okay, we need a positive solution. So we neglect the word, the minus sign. Okay, that means the height must be what? Must be positive. So we can then take the absolute value of minus 30.66. So this will be h equals to 30.66 meters. And this is the height of the castle window above the ground. The noblest pleasure is the joy of understanding. Bye-bye.